Okay, we had a student who sent me an email asking for help on this particular problem. This is a problem from section 3.2, and it's problem number 3 on the homework. If you look at these four situations here, what we're being asked to do is to graph all of these scenarios. So I have to, if you look over to, I went to desmos.com. I use that to graph most of the time. You can use a TI-81, but I'll tell you that desmos.com is definitely a better calculator for graphing. But anyway, I typed in 6x plus 10y is greater than or equal to 120. And then I typed in 15x minus 12y is greater than or equal to 78. And then I have x plus y is less than or equal to 43. So I went ahead and graphed those three equations, those three inequalities, and then I took note here. This last piece here is just saying that x and y are both positive or zero. In other words, we are working in the first quadrant predominantly. So that helps us to rule out a lot of the area where we don't need to be looking. So go to Desmos and enter this inequality, followed by this one, and keep in mind that you're really focusing on the values where x and y are positive, which is going to put you in the first quadrant and on the x and y axes because it says greater than or equal to 0. Okay, so now that we know that, let's go and take a look at the graphs. Once I put those in, I figured out that we have 1, 2, 3, 4 points where any two lines can come together. So let's take a look at that very quickly here. I've got an intersection point here, and I have an intersection point here, and here, and here. And we know that we have to stay on the x and y axis and in the first quadrant. So we're not going to worry about anything that's happening in quadrants 2, 3, and 4. We're only going to focus on basically this shape right here. This is going to be the shape that we're concerned with. I'm just going to do a crude trace here. And so what do we do? Well, if you go back and you look at the problem says that we are trying to maximize z, where z is 15x plus 15y. So let's see, z is equal to 15x plus 15y. Let me try to do a better job on that one. And since we're trying to maximize z, all I'm going to do now is I'm going to go back for these 4 points and I'm going to plug in the x and y values to see what z is. Well, if you plug in the point 10, 6, that's going to be 15 times 10 plus 15 times 6. So if you use the point 10, 6, my calculation gave me 240 for z at x and y. And if you plug in 20 and 0, you end up getting 15 times 20 plus 15 times 0, and that gives you 300 for z. And if we plug in 43, 0, we end up getting z is equal to 645. And finally, if you plug in 22, 21, you end up getting also 645. And in this particular problem, again, we're trying to maximize z. So what's the biggest value of z? Well, the biggest value of z is 645. If they had asked you to minimize z, then of course you would have to pick the smallest z value that you could get from those constraint points. If we were minimizing, we would choose 240. But again, since we're maximizing, we have to pick the 645. And if you go back and take a look at the answer here, you can see that they did indeed accept the 645. So I'll stop here and let you do the rest of the problem on your own. I hope you found that helpful. Thank you for asking.